Welcome to the Encapsulation Challenge exercise. This is the challenge to create a class and demonstrate proper encapsulation techniques, as I've explained in the two previous videos. In this challenge, you need to create a class named Printer. It's going to simulate a real computer printer, a laser printer. The fields on this class are as follows: toner level, which is the percentage of toner left in the toner cartridge; pages printed, which is the count of total pages printed; and duplex, which is an indicator of whether the printer will print on both sides of a sheet of paper. True means it can, false means it can only print on one side of paper. You'll want to initialize your printer by specifying a starting toner amount and whether the printer has duplex capabilities or not. On the printer class, you want to create two methods which the calling code should be able to access. These methods are add toner, which takes a toner amount argument. Toner amount is added to the toner level field. The toner level should never exceed 100% or ever get below 0%. If the amount being added makes the level fall outside that range, return a -1 from the method, otherwise return the actual toner level after adding the amount passed to the method. Print pages, which should take pages to be printed, as the argument. It should determine how many sheets of paper will be printed. It should take into account the duplex value set for the printer. It should return the calculated number of sheets of paper. The sheet number should also be added to the pages printed field. If it's a duplex printer, print a message that it's a duplex printer. In this challenge, you'll want to demonstrate proper encapsulation techniques with this class. Try that out, and when you're ready to come back and see my solution, start the video again and I'll go through it with you. Pause the video now. Okay, how did you get on? Did you manage to complete the challenge using solid encapsulation techniques? Now let's give this a go together. I've already created a new project called Encapsulation Challenge with the usual main class and main method. I'll start by creating the printer class. And I want to start with my fields, adding toner level, pages printed and duplex. All private, following sound encapsulation principles, int toner level, int pages printed, Boolean duplex. Now it's time for the constructor. I only want to have two fields in the constructor parameters, the toner level and also whether the printer is duplex. I'll leave pages printed out of the constructor because that would normally be managed by this class and not passed in when I create a new printer. I don't have to set pages printed to 0 because that's the default value for an instance field that's an integer, but you can always specify it for clarity. I'll do that, but I also don't just want to set the toner level to whatever is passed to the constructor, at least not without validating it first. The rule we set was to not allow the toner level to be less than 0 or greater than 100. I'm going to set the variable toner level to the result of a ternary operation. This .pages printed equals 0. This .toner level equals, and in parentheses, toner level greater than or equal to 0 and toner level less than or equal to 100. If the operation is true, return the toner level, otherwise return -1. Okay, now I've created a controlled way to initialize the printer. Next I'll add the methods I want the outside world to have access to, the add toner method and the print pages method. Starting with add toner, I'll add this method before the closing bracket of the class, public int add toner, and a single parameter of type int called toner amount, toner level plus equals toner amount, return toner level. Here I'm starting out just adding the value of the argument, toner amount, to the current toner level. But this doesn't address the problem of ensuring the toner level stays in the range of 0 to 100 inclusive. Let's type this out and we'll review it afterwards. Int temp amount equals toner amount plus toner level. If temp amount greater than 100 or temp amount less than 0, return -1. You can see here that I'm setting a local variable to toner amount plus the current value of the toner stored in the instance field toner level. Then I test if this variable is outside of the 0 to 100 valid range. If it is, I want to return from the method with a -1. This means that if I get a -1 from this method, there was an error. And if that's the case, I'm not going to change the value of the toner level. Otherwise, I save the new value for the toner level and return that from the method. Okay, I'm almost done. Let's add the last method, the print pages method. Public int print pages, and the parameter is of type int called pages, int job pages equals duplex in parentheses. If the ternary operation is true, return the value of pages divided by 2 plus pages modulo 2, otherwise return pages. Pages printed plus equals job pages, return job pages. Here again, I'm using a ternary operator which tests if this is in duplex mode. Think about what duplex means for a moment. 2 pages will get printed on 1 sheet of paper, but 3 pages will need 2 sheets of paper. This means the calculation I need doesn't just divide the number of printed pages by 2, but I need to add in an additional page if it's an odd number. I do this with this formula that first divides the requested pages by 2 and then adds the modulo value of that same divisive action. The result of the modulo operation will only ever be a 0 or 1. This means when it's an odd number of pages, an extra sheet of paper is included. If it's not duplex, the result is just equal to the pages argument. And I assign this to a local variable I'm calling job pages. Then I add these job pages to the field pages printed. But I return the job pages from this method because I want to report how many pages were actually printed for the current request. And that's the print pages method. The last thing I want to do is to add a getter so that I can actually retrieve the number of pages printed to check that the value was correct. And there's our getter created. And that's my basic class, and I can now go and try using this class. I'll go to the main class, main method, and create a new printer. I'll start it out as a duplex printer with 50% toner level. Printer equals new printer, passing the arguments 50 and true. And I'll print out the number of pages printed with a call to printer.getPagesPrinted. Here again I'm using encapsulation with this constructor and also with my getter, meaning I'm not accessing the field directly, which is correct and what we want to do here. And running that tells us that the initial page count is 0. Next, let's get the printer to perform some work. I'll print some pages, an odd number of pages, to test my calculation for duplex printing. Int pages printed equals printer.printPages, and I'll pass 5 to indicate 5 pages of output. And I'll use printf to print the current job's pages of output and then the printer total pages. In this code, I'm using printf because I have 2 values I want printed, and I'm ending that format string with a %n, which adds a line separator after. And I pass the pages printed variable, which is the pages printed for the job that just ran, and then I use the getter method on printer to print the total number of pages printed. And running that, I get that the current job pages was 3 and the printer total is also 3. Okay, that's good and it's working. So now I'll test printing a few more pages. I can copy those last 3 lines and paste them. I'm not going to copy the int type because I don't want it in the next statement. Then I want to change 5 to 10. And running that, I get the last output as the current job. From this output, you can see that the last job printed 5 pages because I printed 10 pages in duplex mode, and then the printer total is 8 because I ran 2 jobs, and this keeps a count of total pages printed. And I will repeat these tests with duplex mode set to false. I'll just change the value when I create the printer object. And running that. After the last job, I see 10 pages printed with a total of 15 calculated on the printer after both jobs were run. And there you have it. That's the printer class using encapsulation. It's good object-oriented programming practice to use encapsulation, hiding functionality from your other classes. In this case, you can see that I'm not accessing any fields directly, and I've got proper methods that are actually doing the appropriate calculations, adding and subtracting numbers, and performing validation hidden away from the user. Okay, that was the encapsulation challenge. I hope you got a lot out of that. Let's move on now to the next video, where I'll be talking about polymorphism.